Okay, so the tangent has a reciprocal of the cotangent. So you kind of do it the same way that you would do the cosine and the secant, or the sine and the cosecant. The tangent, which you can see here in blue, it goes through the origin. To find b is very similar to the way you would find it with the sine and the cosine and the cosecant. But instead of b being equal to 2 pi over the period, b is equal to pi over the period. So that's how we find b. And the period, of course, is the distance between 2 points on the graph. So you can see between here and here is the period. C is a horizontal shift, so if the graph has been moved left or right along x, we would add or subtract C. And D is a vertical shift, so if it's been moved up or down from the origin, we would be adding or subtracting whatever we've moved up or down the origin. So finding A is a little bit weird. That's the amplitude again, but the way that we find A for a tan is the first thing that we do is we find the asymptote, which is halfway between the two lines of the graph. And then you find halfway between the asymptote and the graph, and then you count up or down until you hit the graph, and that's how you find A. But I will give you an example on the next page. Okay, so when I look at this graph, the first thing I'm going to do is try and decide, is this a tangent or is it a cotangent? And I'm going to look at where the graph crosses the y-axis. So if I look here, there it is, symmetrical around the y-axis, this is going to be a tangent. And because it's not crossing at the origin, but it's crossing one up from the origin, I know that this graph has a horizontal shift of 1. So I know that D is going to be equal to 1 because it's been moved up 1 from the origin, and I know it's going to be a tangent. So those two things I can start with right away. So the next thing I'm going to do is I'm going to see, has it been shifted along the x-axis? No, because it crosses at the origin just up 1, so there is no C here at all. The next thing I'm going to do is I'm going to look for B, and I know that B in tangent is equal to pi over the period. Okay, so now I'm going to look and say, what is the period for this graph? So if I look from this point and to this point, I can see it goes from 0 to pi. So the period for this graph is pi. So B is equal to pi over pi, and pi over pi is just 1. So the period, or the B for this graph, is 1. So finally what I'm going to do is I'm going to look for A. So like I said, A is kind of weird when I try and find it on a tangent. So the first thing I'm going to do is say, okay, so what's the asymptote? So the asymptote is that halfway between 2 points on the graph. So here is the asymptote. As it gradually gets closer and closer, when it goes up and down, it gets closer and closer to pi over 2. So there's my asymptote. Sorry about that. So once I've found the asymptote, I'm going to find halfway between the graph and the asymptote. So here's the asymptote. Halfway between the graph and the asymptote is here. All right, so once I've found that point, I'm just going to count up until I hit the graph. So I go up 1, 2, 3, 4 spaces. So I know that A is going to be equal to 4. So my graph, or pardon me, my function is going to be y, or f of x, is equal to 4 tan. My b is just 1, so I can just write x. And it's been shifted up 1, so plus 1. So here's what my function would be a tan bx plus c plus d. Well, a is 4, b is 1, there is no c because it hasn't been shifted along x, and d is plus 1. So, okay, let's take a look at another one. Okay, so this graph, it's a little sneakier because when I first look at it, that shape looks like a tangent. However, I can see that this graph does not cross the y-axis. This is not a tangent. This is going to be a cotangent. Because it doesn't cross the y-axis, so this has to be a cotangent. Now, why does it look like a tangent if it's a cotangent? Well, remember your a negative a flips your graph. So this graph has to have a negative a because it's not going in the direction that I would think it would. Normally I would think a cotangent would be going like this, or pardon me, did I do, yeah, it's going like that. But an a would flip it over so it looks like that. So my tangent would actually be going this way, and now my cotangent is going this way. So this has to have a negative a. Okay, so how do we find that? So let's start with the things that we know. I know it's going to be a cotangent because this is not crossing the y-axis. So this has to be a cotangent. So I know that. Okay. What is my b going to be? Well, I know that b is equal to pi over the period. So let's find the period. The period is 2. So b is going to be equal to pi over 2. Now I can also see something else about this graph. I can see that it's been shifted up by 1 because here actually is my midline. So I know that my d is going to be equal to plus 1 because it's been shifted up. So now comes a, and remember a is sort of, is a little weird. So I'm going to take a look at, so what's the asymptote? So here's the asymptote, is right here. Whoops, how come it's not drawing for me? There's my asymptote. So to find a, then I go halfway between the asymptote and the graph. So let's go this way. So there's halfway. And then I can go up or down until I hit the graph. So if I start there and go up, I hit the graph at 3. So I went up by 2 or down by 2, whichever. But because I know it's flipped, I know a is 2, but because it's been flipped over, it's a mirror image of what I would expect a cotangent to be. I know a has to be a negative 2. So now when I write my graph out, I know that my function has to be negative 2 cotangent pi over 2x plus 1. There's no c, it hasn't been moved along the y-axis or the x-axis at all. So that comes from this. Okay, let's do one more. Okay, so the first thing again is I have to decide if this is a tangent or a cotangent. If I look at this, this looks like a cotangent to me because a tangent would be going like that. So this looks like a cotangent. Okay, so I've got that. So let's just erase that. So if I know it's a cotangent, the next thing that I have to do is figure out what, okay, let's figure out what b is. So if I look at what's the period goes from here to here. The period is from 1 to 2 is, or from 1 to 3 is 2. So I know that b is equal to pi over the period. So b in this case is going to be pi over 2. So there's my b. If I look at, here's my asymptote. Oh, it doesn't want to draw for me today. Here's my asymptote. There. So it hasn't been shifted along c at all. So there is no c. There is no D. It hasn't been shifted up or down along the y-axis either, so I know that C and D are both 0. So if that's my function, A cotangent bx plus C plus D, I know C and D are 0, so I can ignore them. So the only other thing I need to figure out is A. So to find A, I find the asymptote, so I already drew that in blue. Then I have to find halfway. So there's about halfway. And then I'm going to go up from halfway until I hit my graph. So if I go up from there, I hit my graph at 4. So I went up 4. 1, 2, 3, 4. So my A is going to be equal to 4. So my graph is going to be, there's my function, is going to be equal to, if A is 4, cotangent B is pi over 2, x, C is 0, D is 0, so that is my function. Okay, so I think the most complicated thing with these graphs is finding A. So you find the asymptote, then find halfway between the asymptote and the graph, and then just count up until you hit the graph, and that is what your A is. So A is the most hardest thing to find. B, you have to remember with a tan and a cotangent, it's not 2 pi over the period, it's just pi over the period, so that's the other difference. So those are the two things that are different, and then what you really have to sort of keep in mind is what a minus A looks like. If your graph has been flipped over, what would that look like? Like in our last example, your graph looked like a tangent, but it wasn't because it didn't have that, it didn't cross your y-axis, and a tangent does, and a cotangent doesn't. So if it doesn't cross the y-axis, it's a cotangent, even if it looks like a tangent. Okay, I hope that helped. If it didn't help, obviously, email me and let me know.